Okay, Matthias. Well, thank you so much. And IIF participants, nice to meet you. My name is Danny Huff from Neo Materials, currently residing here as SVP of Strategy and Operations. I am usually in Toronto, but today I'm in South Korea, so it's getting a little late. So if I'm a bit slow today, please forgive me. But I'd love to introduce you to Neo Materials. We are currently listed on the Toronto Stock Venture Exchange under symbol NBM, and we are currently the innovation platform for high performance batteries. And I will explain this very soon. Here is our standard disclaimer. Neobattery Materials, everyone, in a one-line elevator pitch, we are in the business of developing and manufacturing customized high-performance lithium-ion batteries for any types of electronics applications. This includes, as you see here in the image, drones, humanoid robotics, power tools, electronics, EVs, energy storage, you name it. And we are here to remove the performance bottlenecks of all of these battery-powered electronics. And we do this by increasing the runtime of the battery, enabling ultra-fast charging, and most importantly, decreasing the overall costs of manufacturing. And we do this within all of our battery innovation platform and materials. So just before getting on to the company, we would love to provide some context around the growth of the lithium-ion battery industry. As many people may know, the lithium-ion batteries industry really took off with EVs, but we know that the global EV sector has not been doing well for the past few years. However, there is a stronger and much more stable catalyst that is growing the lithium-ion battery sector, and this is artificial intelligence. And just for a disclaimer, that we are not just jumping on a bandwagon, but AI growth has led to real implications for hardware and electronics. With the increase in computing power, this has also increased the need for electricity. So this is why we see a lot of energy companies' valuations soaring. But energy isn't just the full equation, but there needs to be energy storage. So the requirements for energy storage has also expanded drastically with the growth of AI, especially for mobile and autonomous electronics. On the industry side, we see for batteries, there's three key performance metrics that industry manufacturers are always looking for. High capacity, which leads to longer running times, obviously, fast charging with safety so the battery does not blow up, and also having lower costs per performance. And in the industry today, we see that a lot of operations are being autonomized, especially if you did not know, Walmart and Amazon already started delivering packages by drones, all through AI systems. And it's not just the industry that's catalyzing the growth of batteries, but it's also on the policy front as well. Especially for the global battery industry, we are seeing strong trends of onshoring from the upstream to the downstream. And on top of this, there is drastic spending boosts by global governments that are accelerating the need for better performing batteries. And as a few examples, with the recent introduction of the One Big Beautiful Bill from the US, there is going to be approximately about 33 billions of direct spending on autonomous solutions. And autonomous solutions just mean AI-enabled systems and products so that there's no humans needed to operate these types of systems. And 13 billion USD will be put into unmanned systems, which are more for the battery-powered applications. And it's not just US, but also NATO is putting in defense budgets the need for increase in spending in robotics and autonomous systems. So all or most of these systems are requiring for better performing batteries. So it's not more NVIDIA GPUs or more advanced chip technologies that electronics need, but it's actually better performing batteries so that a lot of electricity is stored and a lot of these devices can run for a much longer time than the devices that we see today on the market. So the reason why we keep talking about why batteries are most important for electronics is that The biggest bottleneck for electronics is that finding the right battery is the hardest to do. And as many may know, even generalists know, most of the global lithium-ion battery industry is all allocated in China. So there's this huge dependence on China where approximately 80% of the world's batteries are being produced in China. But when we start talking about smaller electronic devices, batteries for these smaller devices, the proportion goes up much more. And as you may assume, from this high concentration of the battery supply chain, this leads to overall supply chain risk. And recently, with the trade wars, export quotas that have been put on by China and with China, and there has been inevitable price volatility of lithium-ion batteries. And especially the US does not like this type of geopolitical exposure. But let's say you've been able to find a battery outside of China because there are manufacturers such as LG, SK, Samsung, which are the three largest battery manufacturers in the world outside of China that are all situated in South Korea, as well as Panasonic. The problem with these companies is that they operate on economies of scale, which mean that they have product catalogs in which they produce a set number of batteries with set performance specifications. So overall, there is a lack of customization. And because there is a lack of customization, electronics companies like drones, robotics, let's say they want their systems to run for 10 hours, but because of the lack of customization, will only run for 5 hours. And this leads to adding on more batteries, which contribute to more weight. And this leads to overall cost overruns for the downstream companies. And these two supply problems are the most prominent right now for the downstream manufacturers. But there's one overarching problem that layers everything and makes it worse. And this is using outdated technology. Unlike Moore's law in chips and computing, batteries do not follow Moore's law, in which right now the highest performing lithium ion batteries are not very different from the technology that was developed or innovated about 10 years ago. We hear a lot about solid state batteries or graphene, but these materials all have a very long time towards commercialization. So because there is an over-reliance on using legacy materials, this leads to overall performance ceilings for electronics, especially in the aspect of capacity and charging speeds. And if we do not improve these two core performance metrics, there will be a continued inability to realize the full hardware power that is being developed day by day. So this is where Neo Battery Material comes in where we help electronics realize its full performance potential. We are marking our company as a unique Western and North American go-to alternative for customized high-performance batteries. Right now, we are starting off in South Korea, but we are able to deliver industry quality batteries that actually match these performance specifications of different types of system-specific needs. And overall, the company has a mission to go out into North America to start producing batteries locally for US manufacturers as well as European manufacturers, creating a secure and reliable battery supply chain close to end users. And it's not just the same type of batteries that are being made by different types of battery manufacturers. However, we differentiate our batteries with a proprietary silicon battery technology that we have developed for the past 4 to 5 years. And by adding silicon as a special sauce into lithium-ion batteries, we can realize up to a 40% plus capacity increase, as well as decreasing the cost of manufacturing of the silicon materials by almost 60 to 80% compared to our competitors. What we are attempting to do at Neo Battery is not try to beat the industry giants, but we are trying to become the partner of choice for electronics companies that cannot afford compromises on performance. And for the past few short months, we have been able to transition our mission into actual execution and traction. we have been able to gather multi-year purchase orders that total about 10 million Canadian dollars from Asian drone and robotics manufacturing companies. These companies have specifically reached out to us because they have been purchasing one-size-fits-all batteries from China, but these Chinese batteries are not performing to the needs of their actual applications and systems. So this is why we are actively developing and discussing different types of battery technologies that can be implemented into these different types of electronics. And we have two big development pillars. One is with short duration, high power output batteries. And this is more applicable towards drones and power tools that don't need as much as cycle life compared to, let's say, EVs or energy storage batteries, but they really need strong, high spurts of electricity delivery while their system runs. And another big pillar is with more of the traditional EV and ESS batteries, which is more long duration and high capacity, where we enhance the battery's performance with our proprietary silicon materials. So how are we achieving this? And this is a question that comes up because battery manufacturing is very hard to do, just like chip manufacturing. But we have a team that has done it before. Our competitive edge lies within people and experience. And we have a team that's from South Korea that has worked at LG and Samsung, the world's largest battery manufacturers outside of China. We have a team that has commercialized BMW's first EV cells and also scaled gigafactory projects as well. We have also connections within academia, government, and military. So we have decades of practical execution and the know-how to actually scale this project in a phase-by-phase de-risked process. And also we know how to create a robust sales funnel, which is the most important for the top line and the bottom line. So just to explain a little bit more about the products that we actually serve for these electronics makers, the battery making process is simplified into these three steps. First, we have the battery materials, which actually stores the electricity or the energy that comes in. And then what we do is we actually coat these battery materials onto current collectors, which actually deliver the electricity during the use of the batteries. And on the final step is battery cell assembly. And these are the more familiar batteries that you see within the market today. And these electrodes, which are the insides of the batteries, these are stacked and winded and put into this battery cell package. So we at Neo Battery Materials cover from the battery materials processing to electromanufacturing, all the way up to battery cell assembly. So the best way to understand us is the one-stop battery shop for the electronics value chain. And another best way to understand Neo Battery is that we operate like TSMC. So we are the TSMC for batteries. And as you may know, TSMC builds chips, and NVIDIA, AMD, Apple, they design the chips for TSMC to make them. So Neo Battery Materials, we can build batteries according to client designs, and we can help all of these clients actually focus on the end use system rather than spending all unnecessary capex money on building out these expensive equipment. And different from what TSMC does from just building as a tool manufacturer, what we can do is we can also provide customized battery designs for different types of battery makers and electronics makers. And this is much more of a higher margin pillar that we have for the business because it can create additional cash flows via royalties and also licensing out the proprietary battery designs as well. So where are we doing this? And most recently, or very recently, it's been just about a week or two from this news, but we have leased through a long-term lease agreement an operational revenue-generating lithium-ion battery electrode manufacturing facility in South Korea. This facility is located in Gimje City, which is southwest of Seoul. And this battery manufacturing facility has been already servicing major automotive OEMs, car companies that you see on the roads today, as well as servicing global battery startups, both for R&D and commercial uses of lithium-ion batteries. Neo Battery Materials has completely taken over the rights to equipment and production. So at this current time, we are optimizing the parameters, and also we'll be soon commissioning this facility so that we can service the existing clients, but also turn around the manufacturing process or put in different materials for the different drones and robotics companies that we have added into the sales pipeline. And it's not just the insides, the electrodes that we're making within this facility, but as you see here on the second point, we also have the capabilities to actually manufacture pouch cells, which are one of the three most prominent battery cell types that go into electronics. So we can make from small to large scale pouch cells that can be implemented in different types of electronics, but we'll be focusing mostly on drones, consumer electronics, as well as EVs for these pouch cell manufacturing capabilities. And we just don't stop there because there's two more battery formats that are being widely used in the industry today. These are prismatic and cylindrical. And just in an adjacent property from this first facility, we have been able to secure a 3.2-acre expansion facility where there is currently 5 vacant buildings to put in different types of battery cell making equipment. What we are targeting to do is design and develop high capacity cylindrical cells for AI enabled or autonomous systems. And these will be put into humanoid robots, power tools, and different types of consumer electronic systems as well. And on the left, you see prismatic cells, which are more of the square cells. These will be LFP cells, and LFP stands for lithium iron phosphate, which are exceedingly popular in China because of the low cost characteristics. And these cells will mainly be purposed for energy storage and EVs that we will be servicing to different types of downstream manufacturers. Once we put in all of the equipment for the cell manufacturing capabilities, this facility is projected to have an annual battery production capacity of approximately 20 megawatt hours. But just to reiterate Neo Battery's plan, we are not just stopping in South Korea, but our clear mission is to become the North American or the Western go-to alternative for high-performance customized battery technologies. So we have that mission to gigascale this battery production in the North American region. So this concludes the battery making section of Neo's business. And just to jump on a little to the different types of materials that we differentiate the performance of the batteries with, we can introduce you to silicon. So silicon does not replace lithium in the battery, but it replaces graphite, which is the negative terminal or the anode material. What silicon can do theoretically is enable ultra-fast charging, store 9 times more capacity compared to graphite, and lead to cost reductions if it's manufactured correctly. And just as a very intuitive benefit of using silicon, once you put in 10% of silicon within the battery, it can increase the anode capacity to about 30 to 60% while decreasing the weight to 20 to 40%. So this is why before solid-state batteries, silicon is recognized as a must material that must be put into batteries to enable the performance characteristics that electronics manufacturers are looking for today. But there's always a catch in using these types of magic materials. The critical problem of silicon today is that silicon expands by about 300 or 400%. And you can imagine a balloon growing, and if it becomes too big, it pops. And the same chemistry or the same physics applies here to silicon. Silicon can become too big and it can start cracking. And this cracking can lead to performance degradation issues. So this is why solving silicon's volume expansion problem is very difficult within the industry today, unlike different battery materials. So this slide looks very technical, but it's very easy to understand. Right now, on the second and third column, you see here are silicon carbon composites, and silicon oxide materials. These are the most two popular options for silicon anode materials today, and these have been commercialized by different competitors. But where NEO has identified problems with manufacturing these two types of silicon materials is that the input costs are way too high. The inputs used for these materials are usually silicon nanoparticles or silane gas, which is a gaseous, very explosive form of silicon. And manufacturing this is also very expensive because they use processes called chemical vapor deposition, which is a dry process, but it uses a lot of energy. So right now, the average price of silicon is at least 8 to 10 times that of graphite, which is the current material. So this is why Neo Battery, we've taken a completely different approach in using different input materials and also a different manufacturing process. What we use as the input is called metal grade silicon, which is one of the lowest cost feedstocks for silicon that can be used within the battery. And we also have repurposed a decades-long wet milling method to manufacture the materials. So as a result, what we can realize is at least 60% cost reduction to almost 80% compared to different silicon anode options that you see here on the left today. And we do not suffer in terms of capacity. We actually offer one of the highest capacity silicon anodes in the market today. So what we will be effectively doing at Neo Battery Materials is implementing our own proprietary silicon solutions within the lithium-ion batteries so that we can realize much more longer run times, higher charging speeds, as well as an overall lower cost to performance ratio for the different manufacturers that we will be servicing. So we are on the end bits here today, but just as key takeaways for Neo Battery, right now, the next stages for the catalysts really remain with the battery making side of the business. As we said, we're currently within that optimization phase of commissioning the first battery manufacturing facility. We'll be fulfilling these supply contracts that are already existing within the facility, but also fulfilling new battery sales to the drone and robotics companies, and we are expanding the sales pipeline into the US and Europe. So this is what investors should be looking out for in terms of growing the top line and the bottom line in the next coming year and quarters. And on the technology side, we are continually developing the silicon technology, also battery technology with global battery cell manufacturers, as well as different types of electronics manufacturers. And this cooperation is letting us move faster towards the commercialization of high performance cells that perform at magnitudes better compared to the state of the art batteries that we see in the market today. So just to end off with some financials, Neo Battery, we've completed about $10 million in equity capital raising for the past 2 months. So we are well funded into manufacturing the battery electrodes that we currently have within the first facility. And we'll be very soon adding equipment into the expansion facility to start making the battery cells for the different types of client pipelines that we have in the books today. All right. Well, thank you so much for listening, and I guess we will move on to the questions now.
Yes, fantastic presentation, and we already have a couple of questions in the chat, so perfect that we have a few minutes left. First of all, so what chemistry is the focus on, and can LFP batteries also be improved with silicon?
Yes, that's a great question. And right now for the chemistries, we are actually working a lot with LFP batteries as well as the traditional nickel manganese cobalt batteries. So one of the advantages that the company offers is that we have flexibility in using chemistry, which allows us to service all different types of electronics markets. And especially for the silicon technology, there's that flexibility of that being able to be implemented in LFP batteries and also the original nickel batteries. So we also offer that flexibility on the silicon side as well.
And there's a question regarding Altec. That's a German battery manufacturer. I don't know if you're aware of it. And if you are, maybe you can draw some comparison between Neo and Alltech.
I unfortunately do not know Altec, so maybe I'll have to do a little more research before answering that question.
Yeah, no
Sorry about
problem.
that.
But a specific follow-up question for that would be, so do you do any projects already in Europe or Germany specifically?
Yes, absolutely. We currently have different pipelines of different manufacturers that we're working with in Europe as well as Germany. And because Europe is very into EVs, clean technology, but also drone and robotics technologies, we are actually servicing the worldwide market, not just focusing on Canada, US, or South Korea.
Mhm. And the next question um, is particularly interesting because we will later on have some resource companies, but the question is, does NEO have its own raw material deposits, or are you considering that?
No, we actually don't have our own mineral deposits. I think that's a company for its own. I think we're already lifting a heavy weight with battery manufacturing because the economics of battery manufacturing also depends highly on the quality and reducing the scrap rate of the battery. So right now, Michael, we are actually decreasing the scrap rate yields so that we can actually increase the economics. So, Michael, I hope that answers your question in the Q&A box.
Um, So yeah, now that you are continuing the positioning the company as an innovative platform for high performance batteries, uh, which recent developments give you the strongest confidence that NEO's integrated approach from materials to cells is resonating with partners and the broader market?
Yes, where we find that confidence, Matthias, is actually with Asian manufacturers that are approaching us because, as I've explained, the Asian market is the biggest battery manufacturing market, if not all of the global manufacturing market. But even Asian players are finding difficulty of finding batteries that actually work for their specific systems. So that's why we see clear demand that they actually need consultation of battery services from development, design to actual manufacturing. So we've found the traction from Asian companies as a strong signal for the business to go out into this next steps. But we've been also conversing a lot with US, European companies, and right now, the only solution that they have for buying batteries is from China. And right now, with supply chain concerns and especially with performance concerns, they want to divert out the supply chain outside of China. So this is why these continuous increasing discussions with different electronics manufacturers has built a good foundation for our confidence to approach the next steps of manufacturing and also servicing the wider global markets.
Mhm. So we have about 30 seconds left, so maybe you can wrap it up. Why is now the time to buy NEO battery materials?
Yes, absolutely. So right now is the right time for the battery industry because we see that Western governments, especially US governments, are looking to onshore the battery supply chain, and especially the performance of batteries and procuring different types of materials is an expertise that only the South Koreans and the Chinese and the Japanese have. So, what our overall plan is to do is to be a first mover within this battery foundry industry to come into the US because there's no company that offers this type of service and consulting for these types of electronics manufacturers. And once we go into the US or the Western markets, then we can have a stronghold in providing different types of R&D services, design manufacturing services for customized high performance batteries. So it's very advantageous for us to move first rather than wait until the markets pick up. So this is why we see that this is a very strategic time to be within the battery industry.
Perfect. That was a perfect wrap. Thank you so much. I know it's really early or late in Vancouver right now, so thank you so much.
All right. Thank you so much, Matthias.